Good morning. We are going to talk today about the method and a systematic way of modeling electrical systems. So in order to do that, we'll start with a simple example that has some basic electrical elements connected in a series, and we would like to see this as a basic structure on how we produce these models. So let's get started and let's turn our attention to this example that you see on the screen. And let's see if we get my pens working in here. I'll just go and say, well, why don't we put it here, a nice title, Systematic Modeling of Electrical Systems. Okay. Okay. What we are going to do is first recognize what elements you have. So why don't we just write that down? I think that we'll use it blue pen in here. Say, let's just write it down. 1. So we're going to do this a couple of times. Recognize what elements you have. So recognize what elements we said the system has. So that's the first thing that we are going to do. So in the notation that we are using, what kind of element is this one? Right there. Let's change colors here, and I'll just write it down over. This is a source of effort element, right? What about this one here? This is a C element in our notation, right? This is easy also. This in our notation is an R element. And this, of course, is the current that is circulating. So that's the first thing that we do, is to recognize the elements. Now we're going to go to the second step. So step number 2. I'm going to say use a one junction for each distinct current. For each distinct use a one junction for each distinct current. So just distinct. Okay, so now let's just do exactly what we just said. So the one junction is going to be right here, and we are going to call it I for this particular. So this we have done step number 2. On step number 3, we need to say attach the elements that experience those currents. Attach the elements So attach the elements that experience those currents. So in this case, it's very obvious that this current is seen by this source, by this element bar. So in here, we are going to draw that element in here, that is SE, yeah. And in the case of a source, goes from the source into the system, so we will have it like this. And then the C also experience this I, so we'll put it over here. And this one also experience like this, and we put it over here. It is usually a good idea to put the values, the physical values, by using this notation. This is V like this. The value of this would be C, and the value of this is R. See? So that way we make a distinction between the symbol that the computer understands and our actual value. So in this particular case, I would say step number 4 would be I would say complete the causal marks, I am saying this because we are beginning the learning process, but in this case Camp G will do this. This automatically. But it's a good idea that we do it because we are learning here. Yeah.
The one indicates source of flows, right? That's what we
The one indicates the common current. Okay. It doesn't indicate the source of flow, indicates just the common current. The current that is seen by all these elements. So in here you see we put the causal stroke. Let's just get a red pen. For the source it's gotta be like this, right? And then we put it the C in integral form, see, like this. And then of course a one flow to the one junction, this is like this. And we have finished this. This is, we can enter this into Camp G now and get this computer model going. So why don't we try that now, so that you have an idea how we do this with the actual program, and how it is that what we did right now by hand, the computer is going to do for you. Alright, so let's go over here. We go to this okay, we say new. I think it's a good idea that we have our system, or we say our bond graph, in next to it, so that we see what we are trying to do. Let's get this window. See, what we're doing right now is the bond graph on the left hand side needs to be entered on Camp G. So you see, you go in here, you say, okay, this is an AC over there, right there. I'm going to place it on the screen, and then we need a one junction over here. So we're just drawing it, and the way you do it is you pick an element and you pick a junction, and you say from here to here, and see, the computer immediately uses that to assign a number to that connection, but also puts the power flow and the causal stroke immediately. and then this, you put the C element, you want it over here, and you say from here to here, and then you put the R element, which is from here to here. Yes.
Is there?
Huh? So immediately you see there that we had a change in the causal strokes as we completed this. If you make a mistake, just go to the delete and you click on this, and then you see, oh, but look, it reversed this. Well, because right now the computer thinks you only have this element, you don't have the R element connected. But the moment you connect it, then it behaves according to the rules that we want, which is we prefer the C's in integral form, and if the connection is such that this allows to have the flowing into the 1, then the computer is going to choose that. So okay, so there you go. You have entered the entire thing. Now, at this point, it's of our best interest how to create models. We'll go back to this to do the simulation, but let's just go in small steps, okay? Because I would like to see that everybody feels comfortable using the program. Now, in here, this is not just a picture. If you go to where it says Analyze, and you say Explain, you know, it explains whether you have a problem or not. In here, let me move it to the right a little bit so you can see. It has a dialog box on the right hand side that says Explain, and where it says no problems. There's no problems with this in any part of the system. But if you say peak, okay, see that I is for peaking. So if you click in here, it tells you the equations of the different parts, the equations of the connection, the equations of the C. Remember, this is something that we did in exercises a few lectures ago, of each element, what equations each element has. Now, of course, if you keep playing with this, there is a way where you say block diagram. In here, if you click, it'll tell you the Simulink equivalent of each one of those things. See? Just this is something that we see in the presentation of basic elements, right? And that way you can have the display and the Simulink notation for each one of the elements. Like I said, it's important to go hand in hand with the other methods so that we get to learn some more things in how the two of them are equivalent with each other. Any questions about this on how to enter the model now into the computer program? No? Okay. I don't hear any questions. Then we go on to doing, let's just put this one away. Maybe we'll leave it over here. And as we go along, we now I would like to give that a try to a different example. Yeah? So now we should try one that is a little more challenging here, and again another circuit, but in this case I am going to step it up a little bit and do a different example with some more challenging connections.